Welcome to The Explainer. Today we're going to talk about a really powerful way to speed up large language models. And here's the twist. It's not about faster hardware. It's about giving our AI a better memory.
1.24 seconds. Okay, in our world of instant everything, that can feel like forever, right? Well, that's the average time it can take just to get the very first word back from a powerful AI model.
So why does it feel so slow? Well, the reason often boils down to something simple, but super frustrating. Even the fastest AI engines out there can be, believe it or not, really forgetful. They end up wasting a ton of time and energy just redoing work they've already done.
All right, so to really get into this, let's start with the hero of the story, the industry standard for running these models, a system called vLLM.
So vLLM came out of UC Berkeley, and it is an absolute beast when it comes to inference. Its secret sauce? An algorithm called paged attention. It's just a brilliant way to manage the GPU's memory so it can chew through as many user requests as it can, as fast as humanly or, well, machinely possible.
And this really breaks down what makes it so good. It's all about being hyper-efficient, right now, in the moment. It does things like intelligently batching requests together and managing that crucial short-term memory, what we call the KV cache, just to keep the GPU absolutely humming, not wasting a single cycle.
But there's a catch. For all its incredible power, vLLM's memory is, well, temporary. It's ephemeral. Think of it like it only has short-term memory, and this introduces a hidden but really significant inefficiency. Just think about what that actually means for a second. All of that hard work, all the computation the model did to understand the start of your prompt, it just gets thrown away the second your request is done. So if another person, or even you, asks a similar question 5 seconds later, too bad. The system has to start all over again, right from scratch. And that is exactly where LMCache comes into the picture. Now, it's not a replacement for vLLM. You can think of it as an incredibly powerful upgrade that gives vLLM the one thing it's missing, a long-term memory.
The whole idea behind LMCache is persistence. Instead of just tossing out all those valuable calculations, LMCache is built to save them. And it does it in a really smart, multi-layered system that can be shared across different sessions, different users, and even across a whole cluster of different servers.
Okay, so to really see the difference, let's picture vLLM by itself first. It's basically a straight line, a direct pipeline. A request comes in, the engine churns through it, a response goes out. Simple. It's all optimized for just pure raw speed. And remember, all those intermediate calculations we talked about, that super valuable KV cache, it only lives in the GPU's memory for that one single request. As soon as it's done, poof, it's gone forever.
And now, look at this. This is the big change. LMCache basically wraps itself around the vLLM engine like a smart co-pilot. You can see this new layer jumps in before a request even gets to the model. It's managing this persistent cache that stretches from super fast CPU memory all the way to disk and even out to other servers.
Okay, so how does this team up actually work in practice? Let's break it down.
All right, a request comes in. The first thing that happens is LMCache checks its memory. It's basically asking, hey, have I seen the beginning of this prompt before? If the answer is yes, that's a cache hit. It just grabs the precomputed data and hands it over to vLLM, letting it skip all that initial hard work. If it's a miss, no problem. vLLM just does its thing like normal, and LMCache is right there to save the new result for the next time.
And the really cool part is that this whole idea scales beautifully. You can have a whole cluster of servers, like in this picture, and they're all connected to this one shared collective memory. So think about it. A calculation that happens on server 1 can instantly help out a user who just happens to land on server 2. The entire system gets smarter, together.
Okay, now for the fun part, the proof. What actually happens when you combine vLLM's raw speed with LMCache smart memory? Let's look at the numbers, because honestly, the results are pretty staggering.
Remember that time to first token we talked about at the beginning? That wait for the first word? It drops dramatically. We're talking nearly 7 times faster. That feeling of sluggishness, it just melts away.
Next up, throughput. That's just a fancy word for how many requests the system can handle every second. Well, it skyrockets by 82%. That means you can serve way more users with the exact same hardware. That's huge.
And this might be the most important one for a lot of people, cost. Because the system isn't redoing work all the time, the cost for every 1,000 tokens just plummets by 64%. So it's not just faster, it's massively cheaper to run.
I mean, just look at the whole table here. The impact is just undeniable, right? You see that time to first token going from over a second down to almost nothing, 0.18. Throughput practically doubles. And check out the GPU utilization. It drops by 45%. That's the smarter not harder principle in action, and it leads directly to those massive cost savings we just talked about.
So, what's the big takeaway here? It's really important to understand that these two things, vLLM and LMCache, they aren't competitors. They're the perfect team, each playing a totally different but absolutely vital role. The best way to think about it is like this. vLLM is your high-performance engine, built for pure, raw speed. LMCache is the smart navigation and memory system built around it. It makes sure that powerful engine isn't just spinning its wheels, wasting fuel on the roads it's already been down.
So you put them together, and you really do get the best of both worlds. You get a system that's not just insanely fast and scalable, but one that actually gets smarter and more efficient the more you use it.
And that leaves us with a really interesting thought to end on. As we're all chasing the next big leap in AI performance, maybe the future isn't just about building faster and faster chips. Maybe the biggest gains will come from building smarter systems. Systems that, actually remember what they've learned.